All right, so here are a few examples of alkyne reactions. The book doesn't present you with any questions themselves, but it's always a good idea to know what's going on with these types of reactions. You are expected to explain why alkynes consume twice the many moles in addition reagents than alkenes do, and it's all based on that triple bond. So briefly, we are going to go through these right now. The first one we're going to see is the hydrohalogenation. So the hydro being the hydrogen aspect, the halogenation aspect is halogen, and that's row 7 of your periodic table. So fluorine, chlorine, bromine, these things. So when we have our alkyne structure shown here, that is going to react with hydrogen bromide. What I've done is I've broken down hydrogen bromide's moles into 2. So instead of just writing a 2 in hydrogen bromide, I'm showing you both of those molecules there, just so we have a better understanding of what's going on. So one of these hydrogen bromides is going to come into this alkyne, and it's going to break down that triple bond into a double bond. So we're going to move from an alkyne to an alkene. Okay, so I'm just focused right now on the S3, CH3. So the bond's been broken, but I haven't put hydrogen bromine anywhere. So because we've lost that triple bond, this carbon and this carbon are missing now a fourth bond, and that's where the hydrogen and the bromine is going to come in. We would follow Markovnikov's rule. It's just in this particular example, both of these carbon are naked, essentially, so it does not matter which structure you put the hydrogen on or the bromine on itself. So that's going to have bromine, that's going to have hydrogen. Okay. From there, we can then take the other mole. Okay. So just moving down, and that hydrogen bromide is going to come in, and it's going to break down that double bond into now an alkane. Okay. And that would be your final structure there. Okay. Similar things going on with halogenation here, except now instead of it being with hydrogen, now we're just working with bromine gas. We're not concerned about Markovnikov's rule here. Again, so one of these bromines is going to come in and it's going to break apart that triple bond. Sorry, I was just looking at my notes. I thought I wrote something incorrectly. The H. And then, of course, because that triple bond has been broken up, bromine can actually attach on to both, filling up the 4 bonds required. Now, at that point, just like what we saw with hydrohalogenation, this bromine is going to come in and it can break now down that double bond into now an alkane. So we're going to have bromine, still the hydrogen, and then the remaining bromine will also attach on. And then we are also left with an alkane. So just 2 examples there showing that. Again, it's all where the functional group is. I've broken down the number of moles so that you see specifically, like, okay, this hydrogen bromide will break down the triple to the double, and then the remaining hydrogen bromide is going to go from the double to the single.